In this video, I wanted to start off and introduce Chapter 2, which is on weighted voting systems. And the main thing we'll focus on in this chapter is what happens when the voters in a system don't have the same number of votes. And what I wanted to start off with is, well, what sort of situation would that make sense for? And get into basically analyzing the power dynamics of the implications of people having different numbers of votes. And the title of chapter 2 is the mathematics of power, and that's kind of what we're focused on in this chapter. Is how do the amount of votes each player has in the system, how does that affect their power in the system, and what sort of paradoxes can occur in those given scenarios? Let me get the PowerPoint going, and there we go. So yeah, let's start off by getting into the terminology and kind of I'll introduce a sample problem that we're going to be looking at. So consider a publicly owned company with, let's say there's three owners, three individuals who have stock in the company. Let's say that one person owns 50% of the company, another owns 40%, while the third owns 10%. If we were thinking about those three people, and let's say they all wanted to make a decision for the direction of the company. Let's say that some of them want to expand the company, whereas the others don't. Like, they need to come to a decision. And just like, in the last chapter, we could have an election or, try to determine what to do based on a vote. But it wouldn't necessarily make sense for each of those three owners to all have one vote. I mean, in some situations you might argue that could make sense, but additionally you could argue that, well, the person who owns more of the company should have more of a say in that decision. And so that's kind of what we're going to be analyzing is what makes a fair decision and how do the number of votes, play into that. And again, there's kind of an objective quality to this because fair is something that's difficult to measure, and there's a matter of opinion there. But sometimes fair and equal aren't the same. Like in this case, just because they wouldn't necessarily get the same number of votes in like a political election or an election for uh, say a representative or a president or something, it's important that each voter has only one vote, to ensure the equality amongst all of the citizens. But, in certain situations like a corporation, it might make more sense to have a number of votes based on investment because the person who's invested more in the company really has put more into it in the financial sense in this case. But you'd think that they should have more of a say. So we refer to these such situations as weighted voting systems, where the weights are the number of votes each player or each group gets. And I've mentioned the term player, and the players in Chapter 2 are just referencing each of the voters in the situation. But since those voters are often groups, like a lot of times in the ownership of a company, uh, it's not necessarily just individuals that own parts of it, but entire conglomerates or something. So just the term player is sort of referencing each of the voters, whether it be a person or a group. So I'll be using that term a lot, which is a little bit not, a standard term for what you think of. But basically, the players in the system are those who have the votes. And the system itself is called the weighted voting system. And the weights are just how many votes each player has. So in that previous example, let's say that we gave one vote out for each 10% ownership. So the player one, which would be the first owner, we could say that they are going to get 5 votes. Player 2 would get 4 votes, and player 3 would get 1 vote, basically, corresponding to the percentage. And basically, we represent these situations using what we call weighted voting system notation. So the notation basically is something that you'll see a lot in the homework in the book, but it's a way of sort of describing the entire system as a whole, which is set up using brackets. So basically, in brackets, you're going to encounter a number followed by a colon, followed by a bunch of other numbers, where the weights are listed after the colon. So like in this particular example, we would say that, well, I actually wrote it here, so I don't even need to write it. But basically, the first number is always called the quota, and I'll get to that in just a second. But basically, each of the weights would be listed after that. And when I'm looking at this bracketed, group of numbers, basically I can try to read the critical information from the situation. Okay, I have 3 players, and I can see how many votes each player has. in the system. So the other component to these problems is, well, how many votes does it take to make a decision? Kind of like in the last chapter, what's the outcome? How do we make that determination? But in this chapter, it's actually simpler in terms of the outcomes that we're trying to decide in a weighted voting system are not a selection of multiple different things all at once. Like say, in the previous chapter we have 4 candidates, we're trying to figure out who's the best. In this chapter, we're going to be specifically focused on what we call motions, which is just another term for a yes/no decision. And the quota represents the number of votes required to pass the motion. So let's return back to the situation with those 3 voters. The question would be, well, if they all vote, they're going to be voting either yes or no. And that's kind of their only choice in these particular systems. So you could imagine player 1 saying yes. Let's just say player 2 says no, and player 1 says yes to whatever decision that they're trying to make. Basically, that would be 6 votes yes, 4 votes no. And the question is, well, what will happen? And it will depend on the quota, because usually you would think, well, majority rules, so more votes means it's going to pass. But sometimes the quota is set higher than a simple majority for reasons. But let's say the quota was indeed set to be 6. In that case, the group would make a decision yes, because player 1 and player 3 had enough votes to pass the motion and to satisfy the quota. And the vote needs to meet the quota. It doesn't have to exceed it. So if the quota is set to be 6, if 6 votes are in favor of yes, that is enough to pass the quota. And in all this, there's a lot of stuff that's going on, and we often use coalitions, what we call coalitions, to try to get at this. So let's look at the first example in the packet. And let's just fill in some blank. And again, you can kind of take notes on the terms if you're following along with the printed packet, or again, if you so choose. But let's look at example 1. It says, in this case, it's giving us some numbers. So in the weighted voting system coalition, the first number is 10. Then we got the semicolon, and then 4 other numbers, 7, 5, 4, 3. And then it asks us what are each of the terms from this thing. So how many players or voters are there? So and this is usually something where I'd ask you guys as a class to sort of tell me what's the answer, see if you guys if this is making sense. But notice that we have 4 numbers after the semicolon, or sorry, the regular colon, not a semicolon, which indicates, okay, we have 4 voters, and sometimes the book uses n. In this chapter, it always uses capital N to describe the number of people, or the number of groups, the number of players in the system, to which we have 4. So remember, the first number is it's not corresponding to the weights of the players. It's just the first number is always a quota, which is something different. W1 would stand for the weight of player 1. So each one of the weights, we differentiate by the number of the players. So if this is player 1, this would be weight 1, weight 2, weight 3, weight 4. So in this case, W sub 1. If I ever say W sub 1, that's just like a slang term in the math side for subscript, which is what it means when you have like a variable with a little number next to it. It's just sort of a way of, we're using W to stand for weight, and W sub 1, 2, 3, 4 stand for, individual different members of the group as well. And so, W2 would be not a tax form. It would be 5, W3 would be 4, and W4 would be 3. And it's always corresponding to the player. And often when you see the later sections when you're talking about coalitions, oftentimes it will reference players like this: player 1, player 2, player 3, and it's kind of have the same meaning. P for player, subscript corresponding to the individual number. The quota here is 10, which our book uses Q to denote in this notation. And that always means the number of votes required to make a decision, either being a yes or no, in the context of the motion. And so you could kind of imagine, well, in what ways could this group of 4 people pass the motion? And that's kind of what we're going to be looking at soon in the next video. And V, I didn't actually mention that before, but V describes the total number of votes, or total number of weights, I guess you could call it, But basically, what's the net weight of all players involved? So if we add up the other four numbers, again, not including the quota, that would be 12, 16, 19, which is what capital V stands for. And that's helpful for analyzing the terms like majority.